Welcome to section 7.7, complex numbers. Alright, so we have the imaginary unit I comes about from complex numbers. So what happened before was, if you recall, when we were talking about the square root of something and we have an even index, like 2 or 4 or so on, and we have a negative number on the inside, we used to say this was undefined or not a real number. But a mathematician came along and decided to create a number from this and call that number I. So we call it the imaginary unit because it used to be thought of as not real, hence imaginary. But it became a number I, which actually does have applications in real life. And I can show a video on that if you would like to see that video. Just go ahead and send me an email and I can let you know more information about I. But basically we're just doing a very small, brief introduction on the complex number I. It doesn't have too much applied to it in this course. It's just a small introduction. So the unit I, we define it as I equals the square root of -1, which means if, let's say for example, we squared both sides, which we know we can do from the previous video, what would we get? You get that I squared must equal -1. Okay, so this has created a number that comes from the square root of a negative number from an even index. Okay, this didn't exist before, but it has now been defined and now it does exist. So the meaning of the square root of -b. So any number b, for example. For any positive number, a real number b, the square root of -b equals, and what we do is we're simplifying it. We know that the square root of -b is the same as the square root of -1 times the square root of b, and the square root of -1, if you remember, is I. So we can rewrite this as I root b. Okay, so the complex number. Because when we're working with complex numbers, we're also still working with the regular real numbers we worked with before, we have to have a new form that separates them. So if a and b are real numbers, then any number of the form a plus bi, where a is the real number and b is the imaginary part. Oh, sorry, this should say, I missed this little phrase here, is a complex number. That should have gone right after there. So, if a and b are real numbers, then any number of the form a plus bi is a complex number. So it's instead of a new number, we take the imaginary part, which was defined at this point finally, which actually was a long time ago, but in our course, first time it's defined, and your real number part a. So, for example, if we had the number, you know the number 4, right? You've seen that number for a long time probably. If I want to write it as a complex number, there is no real complex number part, so you just write 0i. But now we've written in complex number form, because looking at this, I would know there is no complex number. There is 0. Okay. So let's take a look at example 1. Simplify the square roots, answer in complex number form. Okay, so simplifying, I'm going to go ahead and break up the negative. See that negative in the root? We know that's -1 times the root of 25. And root -1 is I. And then the root of 25, let's go ahead and we'll simplify that. So it's I, 5. Most of the time, though, people write it as 5i. But if you remember, we need to write it as complex number form. Do we have a real number part? We don't. So it's just going to be 0. 0 plus 5i. And that is the complex number way of writing it. So usually I is at the end. Okay, let's go ahead and simplify this one. We have the fourth root of -2. That's a typo. That should be just a 2. We don't have it defined for the fourth root. So that would be the square root of -1 times the square root of positive 2, sorry. Square root of -1 we know is I, and then the square root of 2, we don't actually know what the square root of 2 is. So write square root of 2. Now this is where it becomes a little hard. To write it in complex number form, we'd write 0 plus, now you'd usually write radical 2i. But this looks a little weird because the question is this radical 2i or is this radical 2i? So to avoid any confusion, usually what I'll do with my radicals, and you've probably seen it, I do a little tail down, and that lets you know that is the end of my radical, so anything on the outside is not in the radical. That's just a good way to clarify your work, so there's no question when someone else is reading it or when I'm grading. Once again, there was no real number part, which is why you have 0. Let's go ahead and simplify this. We have root 54. That's the square root of negative 1 times the square root of 54. Square root of negative 1 is I, and 54, we can divide that. I know that's divisible by 2. I also know it's divisible by 9. So that's root 9 times root 6. So that's me I times, well, the square root of 9 is 3, and 6 cannot be simplified any further. So how do we rewrite this in complex number form? Well, there's no real part, so it's going to be 0 plus, and then we're going to go 3 root 6 with a little tail down here, I. And we're done. And notice I make the i's a little scripted, because if not, and you're writing it with just a straight down I, it might be confused as a 1, and you might confuse yourself when you work. So a lot of times when you're neat, it also just helps you in your own problem solving. Okay, let's take a look at example 2. Multiply or divide as indicated. Answer in complex number form. Okay, so what you might be tempted to do when you see this is to go ahead and put them underneath together, multiply, and get rid of that negative. But that is actually not what we should be doing. Okay, because remember, the rule is you should always simplify out that negative first. So don't do that. Get rid of the negative first time you see it. So that'll be negative 1 times root 4 times root negative 1 times root 9. Then we get our real number parts. And then we can get the I times 2 times I times 3. And we have 2 i's, so that is going to be I squared. And then the 2 times the 3 is 6, so 6i squared. Now, do you recall what I squared equals? I squared equals negative 1. So sub this out and simplify it to negative 1. So this will be 6 times negative 1, which is negative 6. Kind of interesting. A little odd, but remember, first things first, simplify out that negative, and whenever you see an I squared, replace that with the negative 1. Okay, except it says answer in complex number form, which I didn't. So let's go ahead and fix that. So complex number form, we have a negative 6. Ooh, is negative 6 the complex number or the real number part? It's the real number part. It's not the imaginary number. So do we have any imaginary number parts? We don't. So that'll be 0i. Okay, let's take a look at the next one. Once again, we see those negatives in the radicals, which means we should simplify. So that'll be root negative 1 times root 75 over root negative 1 times root 3. And that'll be I root 75 divided by I root 3. Now I divided by I, those simplify out, and we're just left with root 75 divided by root 3. Now when I'm thinking here, I don't know how to simplify root 75, and I don't know how to simplify root 3. But if I combine them again, my brain is thinking 75 is divisible by 3, right? Because 3/4 gives me 75 cents. So that's just root 25. And I can simplify that. That's 5. Okay, I'm almost done. We need to write this in complex number form. There is no imaginary part. We just have the real number 5, but we still need to write it as complex form, so we write plus 0i. All right, one more to go. Let's see, root 32 and root 8. Can we simplify anything with that? First off, sadly, that is another typo. That should be root negative 32 over 8. Please fix that on your notes. Should be negative. Okay, so once again, simplifying, we bring out that negative as soon as possible. And then that'll be I root 32. Oops, dropped that root 2 over 8. A lot going on. So now what I'm going to do is I know 32 and 8 can be divided together, and that'll be 4, because 8 times 4 is 32. So let's go ahead and split that up. We have I root 32 over 8. Then that'll simplify, and we get 4. So we get I root 4. Simplifying that, I can simplify 4. That'll be 2I. Once again, I write the I at the end. And lastly, I need to write this in complex number form. So this time, we have the imaginary part. We don't have a real part. So we'll go ahead and write 0 plus 2I, which is my imaginary part. All right, and that is it for this section. Once again, if you have any questions, any concerns about any of the work, once again, reach out or come by my office hour. Communication is really important in an online course.